Our next example is simplifying a monomial. The first thing we want to do is we want to reduce our fractions. It cannot be in lowest terms if our fractions are not reduced. Then we want to make sure that each base is only represented once in our expression. So we've got an x twice there. We got y to the 6th and y to the 10th. So that common base of 10 is represented twice. So what we want to do first, I would go ahead and simplify this 12 over negative 9, reduce both of them by a factor of 3. It becomes 4/3. So you have 4 over negative 3. Let me just leave it like that, negative 4/3. And then we can do our exponent rules. If we divide like bases, we subtract exponents, so that's going to be x to the 8 minus 1 is 7. And then we got like bases of y, so that's going to be y to the 6 minus 10, and 6 minus 10 is a negative 4. Okay, so this negative exponent is the only other thing that we have to simplify. So what I want to be able to do is have a little flexibility in how to write this. So I already have a fraction started. It's a negative 4, or 4 over negative 3. The x to the 7th is already over 1, so that's x to the 7th on the top, and this y is over 1, but I want to make sure it gets to the bottom, so it's y to the 4th as a positive power. An alternative to doing it this way, go ahead and simplify your fraction like we just did, negative 4/3, and then we can start asking the question, what do we have more of? More x's on the top or the bottom? And we notice that we have one more, we got 7 more x's on the top than we do on the bottom, and then we can take a look at our y's and say, where do we have more y's, on the top or the bottom? And that question is we have more on the bottom, and there are 4 more y's on the bottom. And it gets me to that same form in a little different thought process, but I guess whichever one makes most sense to you and you appreciate more.